Hello and welcome back. Let's do a proof. Let's prove that vertical angles are equal in measure. First, recall the definition of vertical angles. Two angles are vertical angles, or vertically opposite angles, if their sides form two pairs of opposite rays. So, in our diagram here, angles X and Z are vertical angles, and angles W and Y are vertical angles. So if we can prove for some arbitrary pair of vertical angles that their measures are equal, then we're done. Okay. So what do we see here? Well, other than that there are four angles, we have two straight lines. So that means these form a linear pair. So do these, and so do these angles. That means that the sum of their measures equals 180 degrees. So let's decide which ones we like to write out by having our thoughts to the side. So measure of angle W plus the measure of angle X equals 180. Okay, because we may not need to write all four of these equations in our proof. But we want to get to the point where we have the measure of a pair of vertical angles are equivalent. So if I had something like X and Z somewhere, like X and Z, if I could somehow get those two equal to each other, then we're in business. Well, notice that they both have something in common. So that means we can rewrite both of these equations. We can solve for the measure of angle W in terms of the other variables. So what would that look like? Well, for this one, if we do minus measure of angle X on both sides, we would have measure of angle W is equal to 180 degrees minus the measure of angle X. For here, if we did minus the measure of angle Z on both sides, we'd have the measure of angle W is equal to 180 degrees minus the measure of angle Z. Well, if we have this is equal to something, and this is equal to that same something, then it must be the case that these are equal to each other. That's what transitivity tells us. Okay, so hold on. How about we use these to start off our proof? So how did we come to these conclusions? We use the same reasoning for all of them. And that was linear pairs form supplementary angles. So, okay, number one, measure of angle W plus the measure of angle X equals 180 degrees. And measure of angle Z plus the measure of angle W is equal to 180 degrees. Same reason. Linear pairs form supplementary angles. Okay, now what? Well, next we can write these. So we have measure of angle W is equal to 180 degrees minus the measure of angle X, and then measure of angle W is equal to 180 degrees minus each measure of angle Z. That was just the subtraction property of equality. Oops. Sophie didn't like that. Okay, I fixed it. Okay, so, and then we talked about transitivity, right? That these must be equivalent to each other. So let's write that next. 180 degrees minus the measure of angle x is equal to 180 degrees minus the measure of angle z. Transitivity. Okay, we could get somewhere. We can get somewhere. We can isolate. We can do minus 180 degrees on both sides, which would give us this. Again, that's a subtraction property. Of equality. Okay, but we don't want negative measures. We want positive ones. So if we divide both sides by -1, that's legit by the division property of equality. If we divide both sides of an equation by a non-zero number, we have an equivalent equation. So we're left with the measure of angle x is equal to the measure of angle z. Oh, whoops, move this down. Division property of equality. Okay, now where are we? X and z. Oh, that's a pair of vertical angles, and we just showed that their measures are equivalent. That was just some arbitrary pair that we picked, so we can say that that is true for all vertical angles. Therefore, vertical angles are equal in measure. And we're done.